Working with an owner that not only embraced prefabrication, but helped push it makes instituting new processes so much easier. It was great working with HCA as we pioneered into lean construction. Prefabricating the corridor MEP racks here that are shown flying here was probably the major component of our prefabrication efforts at Stone Oak. We shipped the racks in from a warehouse about 10 miles away where we assembled the rack and MEP components with our trade partners. We engineered and modeled the corridor MEP systems to fit within a single rack structure. The only component that we couldn't fit on the rack was the fire sprinkler, and that's more because of the local code requirement that the fire suppression system needed to be supported on its own. We established a universal organization pattern for all of the racks for better consistency in rack structure and above ceiling organization. Each trade and system had its own designated space, and that keeping in mind accessibility for maintenance or any other future changes. Because of the amount of prefabrication, we had 3 different types of wall framing to be done down the corridor walls. And shown in the model here is in blue is the toilet pod walls. The green is associated with the MEP racks, and the red is infill framing that was done around all of those. This was coordinated with local inspectors for rating compliance. It's a little more complicated than just framing another wall adjacent to it down the corridor. It was a cost savings approach, and not only that, but it saved a lot of space by not framing that additional wall. We prefabricated toilet pods, sink walls, head walls. All of those are shown in orange here. And the MEP racks down the corridors are shown in green. There's some red spaces, and those were mainly at tie-in spaces or where the racks would be underutilized. This building ties into an existing facility, and because of that, the existing structure naturally wasn't planned around a prefabricated rack. So we used tube steel to span some of the larger areas between the supporting structure. We wanted to create a light and but sturdy structure to these MEP racks, and so we elected to go with Unistrut and eliminated the bolted connections to save space as well as weight, and welded Unistrut pieces together. Because the time constraint was done off-site, it didn't hurt the schedule. The prefabrication advantage is to have better control over your work environment. Work can be done on the ground level, insulation, welding, a lot of those attachments, even inspections. So we coordinated with the local inspectors to do their inspections in our nearby prefab warehouse. They were happy to do it. They were excited about the process, and they embraced a new process even for them. Each system was extended a little beyond the end of the rack and safely capped and enclosed. Components on each rack were tested and verified as part of a quality control process that we put together, which also saved time on the critical path schedule in the field. Racks were lined up as one portion of the work was completed and staged in a functional sequence. Each rack has its own piece marker, which is shown in the plan, much like a set of steel erection sheets.
The truck arrives at the site with the prefabricated rack. A pretty simple crane lift to hoist the rack up onto the roof or into the side of the building. Here the rack is lowered onto a platform that was erected on the side of the building. Workers then wheel the rack easily into place. Due to the light weight of the racks using the Unistrut system, the racks are easily lifted into place using standard duck jacks by a small crew. After the racks are put in place, crews then anchor it, fasten it to the structure. Once 2 racks are up in sequence, crews begin the infill process.
The funnest part for me in this whole process was seeing the finished toilet pods, an entire room being hoisted into the building and rolled into place. These toilet pods were provided by blocks all the way in Alabama and shipped hundreds of miles in weather-tight plastic. Because of the amount of prefabricated components, we had platforms on each level from 2 different entry points in the building, and that allowed us to load more components simultaneously at 2 different points. The slabs were recessed for the toilet pods to make an even floor-to-floor transition. Leveling the recesses was done to ensure a flat and level application surface. It's a 2-part process that included priming the surface to ensure proper adhesion. After priming, then we applied the self-leveling compound, which was mixed locally. The self-leveling compound was then poured and squeegeed into place.
The pad's final prep was an epoxy adhesive. This adhesive was troweled onto the floor prior to the pod being moved into place. This would help ensure, number one, the pod would stick. Number two, it would also fill up any small voids that might be between the concrete structure and the toilet pod itself. There were some areas where we were installing pods that had specialty placements. This is an example of where we had a priority wall. It was a rated wall that had to be built, inspected, signed off by the city inspector prior to placement of the pod. After the pods have been put in place, you can see the formulation of the corridor walls, MEP systems continuing to be put in place and connections being made to the pods.
The seek walls were supplied by Neopod, which is a local shop. Their quality control checklist provided assurance that necessary inspections were done and helped local inspectors. Setting the head wall units was probably the simplest portion of installing the prefabricated components at Stone Oak. These units were shimmed, leveled, and secured into place with framing screws.